Another relationship that we're comfortable with in practicality and reality is this idea between pressure and volume. And how do pressure and volume relate to each other? If pressure goes up, does volume go up? Pressure goes down, does volume go down? Or is something else happening? Well, for example, say I take a can of paint spray and I released a trigger. Well, releasing the trigger, what it will do is decrease the pressure inside. And when I decrease the pressure inside, the paint, the volume inside expands, and to the point that it needs to be released outside of the spray can. Well, so we get this idea that pressure and volume are inversely related. They are what we call an indirect variation. And how that plays out is that, say we have an initial situation with their paint can here. And I know that if I have a volume of 8 cubic inches, the pressure at that point is 12 pounds per square inch. I'm going to increase the volume to 22 cubic inches. From there, what's going to happen to the new pressure? And what do you expect will happen with that pressure? Do you think it's going to go up? Do you think it's going to go down? These are the questions we need to be thinking as we work through these problems. So I'm expecting that with pressure, if I increase the volume, the pressure inside is going to decrease. So let's see if that's where we go with this particular problem. So I know that I have an indirect model here, and that I know that volume varies indirectly with pressure. As we continue to solve this problem, we have our variation set on up, and I'm ultimately going to try to figure out what this new P is at. Well, once I looked at that and wrote down my equation, my indirect proportion I put in is accurate, but I know I'm ultimately going to want to solve for P. So I can also write this very easily as pressure varies indirectly with the volume. And that's just using multiplying both sides by P, dividing both sides by V, and that gets me another equivalent equation. So regardless, both of these will work. I just know at the end of the day, I want to find a new pressure, so I'm going to set that up as pressure is equal to K over V. So in my initial situation, I know that in the initial situation, I have 12 equals K over my volume, which is 8 at that particular case. Multiply both sides by 8, and I get 96 is my constant of proportionality. Did the first one, I created my equation, I substituted the values, and I solved for K. Now I'm going to go ahead and backfill that, which means I'm going to take my new equation, which is pressure varies indirectly over volume, and my constant proportionality is 96. I take my second situation I have here is, well, what happens when the volume is 22? Pressure equals 96 divided by 22. Gives me 4.36. And it's pounds per square inch. And I hope that answer makes sense. Maybe not exactly was 4 or 5, even though that's what the math shows. I hope even beyond that it makes sense that my pressure is reduced. As I increase the volume, the pressure decreases. And in this particular case, it decreases because we found the proportion of constant, or the constant proportionality for this particular situation.